Hey everyone, welcome back to Merge Conflict, your weekly developer podcast, talking about all things. What do we talk about, Frank?
I think we talk about everything tech, but we definitely talk about mobile. We talk
Yeah,
about AI because I force
yeah.
us to.
hmm
And we talk about basically Nintendo and whatever IoT device you bought that month.
Yeah.
That's what we talk about.
Maybe. We
Right
recently
here.
talked about how things work. We've been on a how things work spree, and I was thinking, because you recommended, so I didn't have to do any thinking, was changing it back to your favorite topic, which you mentioned earlier, which is a little bit of artificial intelligence. I don't know if you heard of it, Frank. The idea is that there's intelligence and it's artificial.
Ah,
And I figure we should get back to it because no one else is talking about it. So if we don't talk about it, then,
well,
who are we?
or you know who we are. We are the conflict creators. So I have a
Yeah.
conflict to
Okay.
propose. Okay.
Okay.
Here's the conflict. Um, Are the networks that we're using actually intelligent? We keep using the word AI,
Mm.
but there is this definition for intelligence out there. It's maybe not the greatest one. It's the one you can look it up in the dictionary. Basically, how fast can you adapt to a changing environment? And, the current neural networks and the AIs out there, they're useful. I think they're very useful, but are they intelligent? And at the same time, James, I want to say, I hate this question. And yet I've been asking myself it a lot. And yet I hate the question. It's a useless question because what I think is all that matters is whether neural networks and AIs are useful. That's all that really matters. But every so often, you have to ask yourself, are they intelligent? And how does one answer that?
I think it's a good question. It's something to ponder, I believe, as well. And it's sort of like, why is a piece of clothing or a baseball card or a device worth a certain amount of money, right? Is it because we perceive and we put a value on it? So what I'm saying here is the intelligence that we're saying, are we defining, just like we say that this thing is worth so much money, that this intelligence is intelligence because we've defined intelligence as a society, or we've agreed upon the intelligence on it? Or is it
Oh my God.
because the AI, the artificial intelligence, is actually intelligent? Now, I would say this: it's not like it's saying robots are intelligent. It is saying artificial intelligence. It's not actually. There's like tense there or something, like
Uh,
intelligence versus intelligent. Is that a thing that we could lean on for this conversation?
I'll put words in your mouth. Are you saying intelligence is a spectrum? Maybe it's you can be a little low, you could be a little high on it. It's not are you intelligent or not. Maybe things can be semi-intelligent. A
It's
little.
sort of
And
as
things can
if
be a
we
little more intelligent than other things.
we have IQ tests, which stands for intelligence quantum
Quotient. Quotient.
quantum quotient, intelligence quotient.
It's a ratio.
Is that a test I need to take? Did I
Don't
take
take
that
it.
test?
Don't take it.
I
The
gotta at
only
least
thing
be
the
two out of five. That's up there.
all it predicts is whether you would survive going to a US college. That's the
Yeah,
only thing the IQ test predicts.
I did a lot of
um
AP tests, a lot of
did you?
advanced
Yeah. But
placements.
those
I got,
aren't
yeah, they're not
so those
IQs.
and that's a great place to start. Those aren't intelligence tests. Turns out those are knowledge tests.
Mm.
And okay, let me start with I hate everything I'm about to say because at some level, all we're doing is playing games with words, defining words, and then guessing whether something fits into that category of the words. We're building on ontology, we're redefining the ontology, we're complaining about the ontology. So one part of me really hates what I'm about to do. But that said, you can think of intelligence as multiple things or whatever. we'll go with we'll go with intelligence for now. Skills. Can you do something? Knowledge. Do you know stuff? And then the actual thing that intelligence is, can you adapt to new environments?
Mm.
Can you adapt to new problems? That's actually what an intelligent thing is. But I think what we've discovered is the current neural networks out there, the current AIs out there, are actually really good at the knowledge and skill part. They are really good at learning things if you make them big enough, spend enough money, and skills if you can define the problem and teach it that skill. They can learn that skill. Where they've failed so far is a little bit on the intelligence part. But I do want to give compliments out there because, knowledge and skills, those are very useful things. And
Yeah.
people are profiting.
I think if you were to find this in a object that we might have in our house, let's say it was a robot that cleans your floors. Now those have computer parts in them. They have software that runs. They have a lot of sensors. They're collecting a lot of data. They're applying rules to that data to make educated decisions to either avoid, run into, take a right to a left. And there's a spectrum of robots. There are robots that just run into things and they're like, I'm going to try to not run into things by running into everything.
Yeah.
And then there are other ones that are like, I'm going to do a pattern because patterns to me are smart. And that means I will cover space. And then there's additional ones that are further on that are able to map and plan and make more educated guesses. So I guess the question is, of a robot that's cleaning my house, is there intelligence there, or is it just knowledge and skill that is being applied in this factor, or have we breached into the into there where this thing is intelligent? Because if I put a sock on the floor, I move a chair, does it have the intelligence to understand what that stuff is?
Right. And this is the trap that I really hate, because now we are just arguing about the definitions of words. So I would argue that what it really has is a skill. The skill is to cover an area. The skill is an advanced skill. It can handle furniture moving, but it's not adaptable to anything properly new. Like, can it do a lawn? Like, apply your same thing, but now do an external lawn? No, because it's used to bumping into walls and things like that. Doesn't have the sensors. But again, we're making weird arguments there. Is it intelligent? It's definitely on the spectrum. But I would argue it's kind of on the left side. The left side is poor intelligence.
Yeah, there's like a barometer, right? There's all the way up to the full super intelligence type of thing, quantum computing intelligence. But I think that when I think about what I'm doing, I also think that when we talk about AI and we talk about intelligence and knowledge and skills, we talked a little bit about AP tests. And AP tests are a little bit fascinating, by the way, because it is specific around a topic. And it is a knowledge test. So maybe it's an AP history test or AP calculus test. And if you think about it, what that means is that we've trained our brains on knowledge, on history.
Yeah.
We've absorbed American history, European history that we're at least made to be told is true into our brains. And we then regurgitate it in answering questions. Like literally in that case, we are the GPT, right? We are diving deep and we are trying to pick out these things and regurgitate it up in a way that we remember. It's a knowledge test, but it's very specific, right? And I would say that this is of interest because as we look at GPTs and models and LLMs, all these things, there are ones that we've talked about that are general knowledge. And then there are very specific models assigned to do a specific thing. And I think what's fascinating about that is that the specific model may be perceived to have larger or better intelligence around a specific subject than a generalized LLM, right? So the SLM, small language model, might actually perceive very specific things, have a bigger and better intelligence, but it might just be around how to, regurgitate 1776, for example. Like it might only know everything about 1776 and only about,
right. It's a terrible way to learn, but yeah.
Yeah. It's almost 4th of July. Happy birthday,
Oh,
America. We
happy.
did it.
Good job, America.
Good job, America. We did it.
Right.
Yeah.
Speaking of the British, um, so the current batch, let's call it the current state of the art in AI, is really good at those AP tests. Like they're taking the LSATs, the SATs, all the AP exams. They're rocking it. I think they're scoring 1,000 IQ. That's not true,
Ooh.
but they're doing a great job. All those history things. Because the knowledge one, yeah, you just need a big enough network. It turns out they can retain knowledge. Um, who would have thunk? Um, and then for anything that requires basic skill like solving math problems are within some level solvable by a lot of these language models just because they come up. There's lots of examples and things like that. And so the current batch scores really well on all those tests. And that's why I would argue that those are not intelligence tests. Those are purely knowledge tests. They're exactly what you just said. They are memorize something and regurgitate it. I think the current trend of AI scoring so well on all these standardized tests really shames those tests because that means all we were testing on these poor students was their memorization skill. And hate to say it, but you're born with a certain memory capacity, and you're gonna be stuck with it. And
Yeah.
it's super biased. So anyway, I would like to see intelligence tests, and I don't want to keep talking broadly because I ran into something that I have been obsessing over a little too much, James. I really shouldn't be obsessing over this, but it started with just a peek, and then I just fell into the rabbit hole, and I hope to get out of it soon. And I think that maybe if we just talk it through a little bit, if I talk it through with you a little bit, you can get me out of this rabbit hole. And but maybe first I'll describe the beautiful little rabbit hole that I'm in right now.
I'm ready. I'm ready to go deep down the rabbit hole with you because you shared this, and I don't quite understand exactly what I'm looking at. But I would say that you shared a link with me, and I was like, "Oh, this looks like something that Frank would build." That's what I thought immediately. Okay. By the way, so
it's a little programmer art. Everyone, I hope we'll put some links in the show notes. Yeah,
I actually
what are you gonna say?
I actually thought that it looked like Brian's brain. Brian's brain.
I don't know.
Cellular automata.
Yeah.
Yes. Yeah. So that's what it reminded me of. So Brian, you can Google with Bing the Brian's brain, cellular automata. Now, when I was back in my day, Frank career, when I was writing WPF apps, when I was writing WinForms apps, and I specifically made cellular automaton simulators.
Cool.
And they were really cool. You could Conway's Life. You could load up all these different ones, and they would spatter, and they would do things. So that's what this reminded me of.
Yeah.
But once I did Brian's brain and the cellular automaton generator, this was in university. How was it in high school? Maybe university. I did a zombie simulator. So what I did is I took the concept of, there's a whole concept of cellular automaton simulators and blah, blah, blah. But the zombie simulator enabled you to set up a grid system because everything was just a pixel on the screen, and you could assign randomly generated number of zombies, number of townspeople, and then you had like weapons, like in like how much food you needed and what your food burned. It was basically Sim City of zombie simulators. And you would look and you would see people would all hoard together, and the zombies would hoard together, and they would come after each other. It was like really fascinating. I had all this stuff. If I can find the logic, it was C++ app. No, it was C# app. Might have been. It was WinForms, so it must have been. It was amazing. Anyways, that's what this reminded me of. If you can picture Brian, well, you just go to the link in the show notes, and then it'll be there. So I guess that's what it reminded me of. Gliders and stuff.
There's a lot of things we can describe it roughly as. Pixel art. Cellular automata, because grids, pixels, grids, whatever. I like pixel art though. Let me describe the rabbit hole. Let me take one little step back a little bit. Okay, here's the thing: it's an AI competition. There's an AI competition. Make a thing that can solve a problem. Okay. what's distinguishing this competition, or what they're attempted to distinguish themselves from other competitions, is knowledge ain't going to do it. Skill ain't going to do it. Your thinger is going to need some actual intelligence. Now, how, James? How are they going to actually test if your thinger, let's call it a neural network, because most of these thingers are going to be neural networks. How can you test if it's actually intelligent? Well, they're going by that definition that I used earlier. Your ability to adapt to new problems. That is the definition of intelligence that we're going to go for. And to that end, here's the competition. Given a couple examples of a puzzle, and then a puzzle, solve the puzzle. Oh, and by examples, I mean solved version. So like the starting state of the puzzle and then the end state of the puzzle. So given 2 to 3, 4, 5, a few examples, just the start state and the end state. And now here's a new puzzle, solve the new puzzle. So what your thinger has to do is, from the examples, figure out what game it's playing, and then go on and play that game and win it. Not only figure out the game, but win it too.
Yeah.
And so this is, gosh, when I first looked at it, I was like, that looks kind of easy. But the more I've thought about it, the more I've worked on it, the more I've realized this is an incredible competition. Because there's not just one game to learn, there's hundreds of games to learn. So you can't just train a network to get good at one thing. What it has to get good at is getting good at new things. And I love this competition, James.
So when you think of a grid, the first things that came to mind with me were the cellular automaton stuff, but also Picross, which is one of my favorite games of all time. And the Nintendo version specifically, where you're making imagery out of, I'm a big math person. So the fascinating part about this challenge is that it's not like Sudoku. It's not like Picross, where there's numbers, there's math, there's a set amount of rules. What's fascinating about it is that there's, in the public training set, and there's 2 different modes. There's an easy and a like a normal or advanced or whatever, but there's 400. But the rules of each of those games are different. So for example, on the first game that I'm on, which is actually 2 of 400, I forget to the first one, but the first one I figured out, right? So there's a grid, and let's say it's making a shape. And in this instance, a few of the shapes before, you can imagine, let's say there was a square. So there's a green square, and then the output is the green square, but now the green square's center is filled with a different color. And then below it is some other entities. And again, the spots that had fully been enclosed are now filled in the next one, right? But if you go to the next game, it is completely different, right? And there's colors and there's sizes and there's shapes. And the grid sizes are different. So for example, in the next game that we have, it's that there's an input that is a 3x6, but then it becomes a 3x9, so lots more rows, and it's an extension of the pattern, right? And the color changes. And then the next one, for example, I have no idea what it does. What is this doing? Oh,
no,
what is it doing?
It can be hard.
Yeah, James, I actually don't know what this is doing.
I'll tell you. I'll give you a second, because when humans try to solve these problems, and here's why we think it's an intelligence test also. Humans, on average, your average human being person can solve 85% of these puzzles. And so I have faith in you. I think if you stare at it, some of them are hard, I'll admit.
Yeah.
There's a couple that I've noped out of. Like I'll stare at it for a good 30 seconds or a minute. And if I don't get it, I'm just like, there's others to look at. I'm trying to look at a data set and things like that.
This one's hard. There's multiple kind of shapes, squares and different things that have hollows. But what it does is the bottom right shifts over one column to the left on any shape that's publicly visible. So anything that's in the, I don't even know how to define what you would be doing.
Yeah.
But you would basically, there's always a shape that's kind of like a Tetris block that's like an L or an elongated L, but it shifts that L one over on any of the shapes that are publicly visible. Oh, very, yeah, exactly. That's what it does. Very fascinating.
Right.
The next
and
one,
how many words did that take you to explain? So,
and I don't think I explained it. I didn't explain it well at all, by the way. That's
right.
Terrible.
Yeah. And the problem is you can train a network to solve that problem you just said. No biggie.
Yeah.
They only give you a couple examples, but once you solve it as a human being person, you can start coming up with other examples, and I can start generating examples, and I can train a network to, in the general case, solve that problem.
Yeah.
But that's not the competition. At the competition time, that problem's not going to come up. There might be a variation on it. But what you said, I wasn't really paying attention to your explanation, but somehow it selects some shapes and then moves them to
Shifts
the
it.
bottom. Yeah.
Yeah.
There are other ones like count the number of pluses and sort them by the count. So it's a count and then a sort, you know? So it's not just a selection. So there are general purpose computation things that happen in here. There are imaging things that happen in here. Sometimes just an image will come up and a part of it will be masked out, and it will have to do a smart fill. It's like a Photoshop operation.
Yeah.
So, they can learn how to do that because that one tends to come up in other things, but some of them will be very simple. Flip a shape. So your thinger has to learn how to do a simple one. But then others will be very complex, like keep bringing it up, but like Sudoku. It's in there. And so A has to recognize Sudoku from a few examples, and then B, play it. So fine, sure, I can train a neural network to play Sudoku, but one more time, that's not going to be helpful because at test time, Sudoku's probably not going to be in there.
Yeah.
So what a wonderful test. What a powerful test that they've presented.
Now, you said this isn't like necessarily the first time that they've done something like this, right?
Right. I don't know how far back this goes, and we should probably say, I apologize to everyone. This is the ARC AGI contest, ARC, AGI for Artificial General Intelligence. I don't know what the ARC stands for. Doesn't really matter. ARC. It is a competition hosted at Kaggle. So you can just search Kaggle, but you'll find, I think it's been running since 2020, but don't hold me to that. I don't know the full history of it. James, I have a problem. I like to go into problems really naive. There is a lot of information out there. There are whole discussions. You can look at other people's code on how they've tried to solve it and things like that. I've avoided all of that stuff. I like to approach problems myself, and while deep in the rabbit hole, I like to be a little bit blind. Who needs a flashlight? You don't need that stuff. And so I don't know actually the details of how long the competition's been going on or anything like that. I really just know the current state of it.
Nice. Yeah, it's a really fascinating competition because there's also prize money behind it at the same time.
Mm-hmm.
Like they run the different models that are out there today against this. And when we say that it's a relatively sort of advanced thing that it's hard to train, if you just ran Gemini 1.5, the scoring on it is about like 8%. And GPT 4o, 9%.
So, wait, even. Okay, pause.
Yeah.
You got to remember, a human being, anyone, not smart people, not any human being is going to score 85% on this thing. Yeah. So think about how low that is. And also keep in mind, these are models that score 85% on the LSATs and all your AP history exams and that kind of stuff. So really think through that dichotomy. Really think through, okay, these networks that are, Gemini is really advanced. GPT-4o is really advanced. They're very useful. I use them every day. They help me write code. They help me to do everything. But they're terrible at this competition, James. 8%. Yeah. 8%. Okay, please continue now.
Yeah, I mean, I just think it's really, really fascinating to kind of watch this as like the training data goes in. And like the cool part is that you can link to all of them and you can actually look at the results and the inputs and the outputs and how they're piping data into it as well. And so far, the highest, which I think is Ryan, so a person, is scoring 42%. Hello, Ryan. Now, Ryan created something, right, to actually diagnose and figure out how to create a model that will do this. So he looks like he took OpenAI, and I'm not sure exactly what I'm looking at is code to do, but
Right.
something in
So
OpenAI to do. Yeah.
allow me to explain. And honestly, I'm a little bit new to Kaggle, so I don't fully understand the right way to do everything. But in general, the way you submit to it, like let's say I trained up something and I want to submit it to them, is you submit a little Python notebook because we all just use Python for training these stupid
Yeah.
things. That's just how it is. You live in that world. It's fine. It's fine. So you submit a notebook, but that notebook becomes somewhat public from what I understand. And no one wants to give away their secrets. Like Ryan has created a really smart thinger that in this competition is 4 times more or no, it's I did that math wrong. Roughly 6 times more intelligent than GPT-4o and Gemini, and does not want to share their network. So Ryan has created a notebook that just loads up the network and then executes it, or whatever the thinger is. We don't know the magic sauce Ryan is using.
Yeah. Super magic sauce.
Well, it is super because can you just read through the leaderboard? It's not that long. So Ryan's at 42%. Who's next after Ryan?
After Ryan is, I guess, is Ice Cuber 2020.
Mm-hmm. Ice Cuber. How you doing, Ice Cuber?
Cuber. I think it's like the example that they had basically.
At what
from
percent though?
previous.
What percent?
39.
So pretty big drop. 10% drop.
And then Claude 3.5 is at 21%, then GPT-4o at 9%, then Gemini 1.5 at 8%.
So that's pretty great for Claude because Claude is a general purpose language model. Claude can also do very well at the LSATs and AP history exams and all those kinds of things. So that's really impressive for Claude to be both full of knowledge and also semi-adaptable to new problems. Either that or Claude was trained on a million puzzles, who knows? But I like to think Claude has shown a few signs of intelligence there. But still a far cry from Ryan's thinger.
Yeah. So what does this tell us, Frank, about intelligence? If we go back to it, we have this actual multiple puzzle challenge that humans can score 85%, but the best models in the world are scoring low. Is that telling us that they're intelligent or not? Or is it telling us that the intelligence that we've defined them to have is because we've said that this is what we believe intelligence is when it comes to artificialness?
That's the big question. We don't have an answer for it because for thousands of years we've tried to define intelligence. We don't have a great definition. We don't have a working definition. We definitely don't have a definition that engineers can use. Well, we have a definition salespeople can use, but not one that engineers can use. What I will say, I think that there are very practical things to take away from this, though, and that is there is something lacking in the current set of models. Is that intelligence? Who knows? What it really is adaptability. Maybe we should just throw out the word intelligence and stop conflating the two, and we'll just call it ability. And that's what we kind of want to see. In the ML world, it's called transfer learning or one-shot learning. Basically, you want to create something that learns very quickly and can adapt to new kinds of problems. So I would say that although we've couched this whole conversation and we've had fun using the word intelligence and all that kind of stuff, what's important is, are these things useful? We have current models. They're very useful. But I think what we've also discovered is that they're lacking in this dimension called adaptability. And I don't think we'll ever, because we have this definition of intelligence, we'll never ever call them intelligence until they do start scoring higher on the adaptability. So we need them to present all of these things: knowledge, skill, and adaptability. Because otherwise, we're just going to have to live with 20% scores on very generic puzzle games.
I guess, how far away are we, though, from these models upping
Far.
far, far.
Yeah. Yeah, because this gets a little more. This is both technical and philosophical. It's a tricky territory to tread, but our current set of models are interpolators. They blend a bunch of things they've seen in their history to create new things. It can often look like new thoughts because it's really good at synthesizing and merging things. That's what these networks are really good at. So they demonstrate creativity in that regard, but they are forever constrained by patterns and probabilities and things they've seen in the past. They're great at merging, great at creating a synthesis from that merger, but they're not great at adapting. Whatever word you want to use there, I think we've covered enough what they're not great at, and that's because they're just interpolators. You can give a more mathematical description. A neural network is a manifold in a very high dimensional space, and you are forever stuck on that manifold. You trained yourself, you've trained a manifold, and you are that manifold, and you will never depart that manifold. That is your life. If you depart that manifold, you start generating nonsense and you start hallucinating. You must stay on that manifold. And so what we need are higher dimensional manifolds, higher dimensional. We need meta learners. We need things that are good at learning. That's it.
Yeah. Well, if we were thinking about 20 years ago and we're thinking about what we have today and how far away we are, we could quote and go deep on a movie that talked about artificial intelligence and how you might infuse it and how things may become smarter and adapt all three things. And what I'm talking about, Frank, is a movie set in 2035, which is actually only 11 years away from us, which is a movie called iRobot. I don't know if you've heard of it, but it is our good friend Will Smith in 2024. So 20 years ago, predicting 30 years into the future, with robots that, one, if you think about the iRobot, not to be confused with iRobot the company,
not to be confused with iRobot the books, because they completely changed the plot.
There you go. Yeah. So there are a bunch of, now these robots, they have a set of like rules and regulations that they're defining, right? They're kind of in this Roomba type of situation. However, there is the idea that there are these highly intelligent robots that are able to do the additional adaptability, and then there's ones that break through that are the mega LLMs that are running inside of these. So how far away are we from iRobot, Frank? Are we 11 years away? Are we in our lifetime? Is it ever going to happen? Do we even want that? I don't know.
We are at least one revolution away from there.
Okay,
maybe two revolutions. Yeah. It's hard to say. We're not going to get there with the current state of the art.
I gotta watch.
There's money to be had. You never know when there's money out there to be had. Weird things happen. You know.
That's true.
All of a sudden, you're building rockets that go into space. Weird things happen.
I agree. All right. Anything else you want to talk about this, Frank? And I'm
not sure you pulled
engaging on. Are you doing it? Are you applying something?
I am. I gave myself permission to spend a couple days on it.
Nice.
Those couple days turned into a couple more days, sadly, because that just happens. It's an enticing competition because you can train something that can solve the puzzle 70% pretty quickly and easily, honestly. But one of the big rules of the competition, all or nothing, baby. You solve that puzzle, there are no partial prizes in this game. So it does not help to create a network that can solve the puzzle 70%. That's a fail. That's basically solving the puzzle 0%. So I think that's the enticing problem. Is although I know fundamentally the things I'm using, given our discussion today, can never win. Boy, they go from 70% to 80%. They're like, wow, it almost got that one. And then you're like, is it intelligent? No, but it almost got that one.
Oh, it was almost there.
Yeah, so I don't think you've talked me quite out of the rabbit hole, but I am going to have to depart for 4th of July activities. So I will have to leave the rabbit hole for a while, and we'll see if I ever do fall back into it.
Nice. Well, go off, celebrate America. Now, by the time this podcast comes out, we'll have celebrated. So Congrats, America, you
Yay.
did it. Um, and yes, Frank is going to get very close to visiting me, but not at all. So I appreciate that. One day he'll come and visit me, but we'll see if that ever happens. But that's going to do it for this sad closure of a podcast where Frank only wants to talk to me remotely on Zencaster, and that's it. So until next week, I'm James Montemagno.
And I'm Frank Krueger. Thanks for watching and listening.
Peace.